video introduces independent events and their probability. This is the definition of an independent event. Events are independent if they occur one event and then it does not affect the probability of another. So here's an example. You don't need to write it down. So let's say we have a coin and we toss the coin up in the air and it lands on a head. Okay, so this is your first toss. Then you toss the coin again, and the second toss is independent of the first one. It does not affect the probability of the other. What is the probability that maybe this head would happen again? So you would have a 1 in 2 chance for this one, and then you'd have a 1 in 2 chance for that one. So the probabilities would be multiplied together. So you'd have a 1 in 4 chance of getting a head and then another head, or a head and a tail, or a tail and a head, or a tail and a tail. Each of those scenarios are all a 1/4, a 1/4, a 1/4, a 1/4 that add up to 1. All right, so let's go ahead and figure out this definition. This definition is an equation that we're going to see over and over again. The probability of A and B, if they are independent, one does not depend on the other. You just go ahead and multiply the two probabilities together. All right, so here's that coin. We toss it up in the air, and we're going to do this 3 times. And we want to find out what is the probability that we get a heads, then a head again, then it lands on a tail. So we're going to find the 3 separate probabilities. So a separate probability for a head is you have a 1 in 2 chance, and then a probability of a tail, 1 in 2 chance. All right, so let's go down here. So the probability of a head times the probability of a head times the probability of the tail. So we multiply these together. 1/2 times 1/2 times 1/2. Multiply across your numerators, multiply across your denominators. You have a 1 in 8 chance of landing on a head, and then a tail. Here's another example. Find the probability of rolling a 6 on a 1 number cube and a 6 on another number cube. So we have to think about our sample space. So think about our sample space of 1 dice, okay? We want it to be a 6. So there is a total of 6 different possibilities, and we want it to be a 6. Then we roll again the dice, and it also is going to be a 6. So remember what we do? We multiply 1/6 times 1/6, multiply across. You have a 1 in 36 chance of the same number popping up again. All right. Last example of independent events. You have a 6-sided dice, and it's labeled with the numbers 1, 2, 2, 3, 3, and 3. Now, 4 sides are colored red, 1 side is colored white, and 1 side is colored yellow. Find the probability of tossing a red, then a white, then a yellow. Now notice, these numbers, we don't even have to worry about them. We're only worrying about the colors. So let's look and see the total. 4 sides are colored red. So what is the probability of landing and getting a red? You have a 4 out of a 6 chance of getting a red. Then you roll it again. It says 1 side is white. So you have a 1 in 6 chance of getting a white. And then the last one, probability of a yellow. Well, there's only one of them, so you have a 1 in 6 chance. So now we go ahead and multiply across. 4, and then 6 times 6 times 6. 216. Now again, we want to reduce down. So we reduce it by 4. So we have a 1 in 54 chance of getting a red, then a white, then a yellow.